Welcome to our next lesson. Last lesson we looked at how to get a z-score from a raw score. Today we're going to be switching things around and going in the opposite order. So starting with a z-score, we need to be able to convert that to work out what was the actual score or the original raw score. So previously, that was the rule that we used there. It was our raw score minus the mean divided by standard deviation is how we worked out our z-score. So we're going to be doing the reverse. So rather than divide by standard deviation, we're going to be multiplying. And then rather than subtracting the mean, we're going to add it. All right, so it's going to be our z-score times the standard deviation, and then we're going to add the mean. Now, depending on which notation you will come across, they both do the exact same thing. So where we've got z times that weird looking circle thing is sigma. So z times sigma x plus x bar. Or it's going to be z times s, which is also standard deviation, plus x bar. Remember that the sigma, the weird looking circle in that first one there, represents the population standard deviation, where s just means the sample standard deviation. In the questions of this type, you'll just be told standard deviation, or it'll be written as one of those two, sigma or s. You don't need to have to work out which one to use because you'll only be given the one standard deviation. So you'll be given it to you. So it's not going to be an issue. So example one, we've got a normal distribution where we've got a mean of 30 and a standard deviation of 3.5. Blake has a standardized score of 2 and we want to calculate Blake's actual score. So that standardized score of 2, that's his z-score. So we want to work out his actual score. So it's going to be the z-score times the standard deviation plus the mean. So we know his z-score was 2. The standard deviation we're told is 3.5 and the mean we're told is 30. So x is just going to be 2 times 3.5 plus that 30. Making sure you do the multiplication first, you're going to get that x is 37. So what that 37 is that's the actual score that Blake got. Right? His actual score was 37. Example 2. So there was a class test out of 50 and it had a mean mark of x bar equal to 34 and a standard deviation of s equal to 4. Right? So they're using s here for standard deviation rather than sigma, but it doesn't make any difference. Mary's standardized test mark was z equals negative 1.5 and we want to know what was Mary's actual mark. So we're doing the same thing again. The only difference from example 1 to example 2 is that we've actually got some of that notation in there, x bar, s, and z. Right, so x is going to be equal to z times s plus x bar. It's the z-score times the standardized score plus the mean. It's exactly the same, we're just substituting in the variables for it rather than using the words. So our z was negative 1.5, our standard deviation is 4, so we want to multiply those two together, and then we're going to add 34 at the end. So calculator tells me that that's going to be 28. All right, so that means that Mary's actual score was 28. Example 3. So Jordan has achieved a z-score of 2.5 for a reading test. And the state mean for that reading test was 71.5 and the standard deviation was 6.4. Part A wants us to explain the meaning of that 2.5 score. So what that 2.5 is saying is it's 2.5 lots of the standard deviation from the mean. All right, so 2.5 times that 6.4 above the mean, because it's a positive z-score, it's going to be above the mean. Right, so how would we explain the meaning of that score? Well, it's just that it's 2.5 times the standard deviation above the mean. Right, that's the result that he got. That's where he performs. He is in the top part of the people who did this particular reading test. Part B now wants us to actually find to the nearest whole number what was Jordan's actual score. All right, so we know we've got a z of 2.5, we've got x bar of 71.5, and we've got an s of 6.4. So we're just going to plug them into our rule, z times s plus x bar. So if it's z times s plus x bar, it's going to be 2.5 times 6.4 plus 71.5. and that's going to come to 87.5. But note the question says to the nearest whole number is 0.5, so that means we're going to round it up. So that means Jordan's actual mark was 88 to the nearest whole number. All right, so all of those examples are exactly the same. Now, there might be some questions in the book that ask you to do something weird, like to rearrange a formula so that you get X as the subject given the formula with Z as the subject. If you can remember that X equals Z times S plus X bar, you don't need to worry about that. All right, it's just making the questions harder than they need to be. And that brings us to the end. So exercise 9D on page 360. Don't feel like you have to do all of the questions. I'm more than happy if you just do the odd numbered questions. As always, any questions, feel free to send me an email or a message via Google Classroom. We will be having a Zoom meeting on Thursday. So hopefully you've seen this prior to that. If I don't see you then, hopefully I will see you all when we get back to school in a week and a bit.